Our speaker, Joe Scott, does not really need an introduction, but I will give him one anyway. Joe Scott is a native of California. He came to Utah with his family. He lives in Sandy and works for a company in California called Automatic that runs Wordpress, among other things. A whole lot of stuff that a whole lot of people visit a whole lot. I believe his business card still says Bug Exorcist, unless I'm mistaken. That's an apt description of one of his many skills. One that is not listed on his business card is his skill at speaking and presenting great information that I'm sure we will all learn a lot from. So, take it away, Joseph.
Thanks. So, caveat, this is not my laptop. For some reason, my laptop didn't want to play nice with the projector. Fortunately, I'm generally really paranoid when it comes to presenting, so I had a PDF that we're going to cheat on here. That green is horribly flushed out, too, unfortunately. So what we're going to cover is PHPUnit's code coverage feature. How many people have written unit tests in PHP, or PHPUnit? It's like, I feel like I'm saying PHP and testing too much. Oh, nice. Now the green is shut. Alright, so to get started, there's not too much in the way of exotic things that you need to install. You need a reasonably recent version of PHP. You need a reasonably recent version of PHPUnit. You do need Xdebug, which is what takes care of determining which lines are executing in your code and which lines are not. And you need a module called code coverage written by the same guy who wrote PHPUnit. That's really, this code coverage is really the only one that I would consider kind of maybe non-standard for some of your dev installs. Installing it is not super hard. If you're used to using Pair, you can do that. If you're used to using Composer, there's an option to do that. So it's not real hard to get up and going. Not my laptop, but on my regular laptop, it works fine with MAM. Yeah, thank you. I was drawing a blank on what that package is that I installed once. So let's get into the meat of this. Here's a very, very simple code example of a class that we're going to run some tests on. Basically, it takes a name, and then depending on which name we're given, we're going to generate a different greeting for each person. And we want to run some tests against this. So our first test is very simple. We say we're going to get a new example. We're going to ask it to give us a greeting, the default for Bob, and that's what we're going to expect. This test is going to run, very simple command. Again, nothing exotic. If you've never run PHPUnit tests, this is really simple to get going. It's not hard to do. The output by default is not really exciting for people who've used PHPUnit before. You run it from the command line and you get this, like, well, let's call it very minimal response back. Basically saying, hey, you had one assertion and it worked. Congratulations. You don't even get a congratulations back, but that'd be kind of nice to have. There are some different options that you can throw into PHPUnit. If you want to have a little bit of color, you can ask it for that, and you get this wonderful extra green line saying, hey, congratulations. There are some other formats that I don't really use much, but if you're having to import and export testing data into other systems, they might support these other formats. So TAP is one. Again, not very exciting. Another one is test docs. Again, very simple text-based response. None of it is exciting, right? It doesn't scream at me, hey, congratulations, all your tests passed. So let's use another option. Coverage HTML here is going to say we want a coverage report generated in HTML, so we're going to browse it with the web. And we're going to dump it into this subdirectory called report, and we're going to run our same test here. Now we're going to get something a little bit more from our command line, saying, hey, we generated the HTML. Again, nothing super exciting, but we get to the point where now we have something to look at. And the thing that I want to point out here is the lines number. Turns out we have 8 lines of code that should be executable in our class. Out of that, our test, it's actually 5 of them. This 5 of 8 number here, which gives 62% code coverage out of our existing 1 test for this class. So immediately right off the bat, you get a feel for how much did your test actually accomplish. There's a few other nifty little features in here. Whoops. If you mouse over a line, it will tell you which tests cover that line, which is really handy. In our simple examples, there's only going to be 1 test per line. But if you've got a large code base and lots of tests going on, you might have 5 or 6 tests that deal with execution on a particular line. So it's really nice to be able to pinpoint which tests for a particular line. So we've got this one thing, we got 5 out of 8, which was what, 62%. So we can do better than that. We can add another option that tests a different set of conditions in our code. So we're going to tell it, hey, I want the green integer Jill, which in this case we happen to know is going to be hello, so that test is going to succeed. Again, we crank out our report, and this time it gives you this sort of feel, the red light, yellow light, green light thing, right? Red is really bad, yellow is and green is good. So at this point we've moved from yellow to green. We've got 87% on our 7 out of 8. And we still have this 1 line of potentially executable code that is not getting test coverage. Excuse me. So we go back and we add one more thing. We're going to take care of the jack condition. We're going to run again, and voila, we get 100%. Right? That's pretty awesome. There's some caveats that we'll discuss at the end, but at least this gives you a feeling of how much coverage your tests are providing. Now, this is again, very simplified, not super complex in any way, sense, or means, but it gives you a feel for what it takes to get to 100%. Now, nobody's mentioned something on this report that I thought might come up. Yeah?
Crap.
What is crap? Right? I'll tell you, that's the thing that stood out to me. The very first time I ran this report, and I thought, oh, this is so super handy. I can generate all these things. Did you have a question?
Oh, no, sorry.
Okay. You generate all these reports, and you get this, nice, useful information, and it tells you how much code coverage. Oh, that's great. What the heck is crap? I was at a bit of a loss. For those of you who've ever dealt with Unicode stuff, it does not involve this character. For those of you who haven't dived into Unicode stuff, it does not involve this character. This is the traditional, this is actually a single character in a font in UTF-8. Extended characters in UTF-8 actually have names. This one is called Pile of Poop. And the brown kind of washed out there. I'm glad the PDF exported properly. This was actually a character you can insert in Keynote on your Mac. As an extended font. And you can search for it by the text description. So if you enter in poo into the search field for the extended characters, this will actually come up, and it renders in the smiley face version as opposed to the traditional steamy version. So that's a side note. Crap on your code coverage report does not involve a pile of poo. It actually stands for Change Risk Analysis and Predictions. It's one of those things where you feel like somebody just really wanted to have an abbreviation that spelled out crap. The idea, there is a formula behind this score. And the idea is to give you a feel for how dangerous it is to modify that code. And it's got a number of fields and attributes to it. I won't go into detail on how all those work. There's plenty of documentation on there on on that, but the author of it described it as predicting the effort, pain, and time required to maintain this existing code. And this post will describe the actual calculations involved. I'm not worried about necessarily the calculations. I was more worried about using it to get a feel for how well my code is as far as being maintainable and being updatable. If I'm going to make a change to that code, what's the risk involved in that process? So crap is like golf. Lower is better. Less crap is better than more crap. And the two factors really that I'm going to talk about are complexity and test coverage, are as far as methods for lowering the crap index of your code. So we're going to start with a new example. This is a made-up thing that takes credit card data and it checks for a whole bunch of fields and returns false. And if they were missing, does some stuff with credit card details and always returns true. Again, very simple one. Anybody will be able to follow this. So I'm going to write a test that says, here's an empty array of data. We expect to get a false response back. So again, running this, super simple. Nothing exotic there. And you get something that looks like this in your HTML. So we get a crap score of 25. We only have 18% code coverage. And you can see we've only really tested 2 lines out of our 11 that could be executable in this process. 25, again, this is something, it's hard to compare between sets of code. So this is probably best left to only be compared to itself. So don't necessarily compare this 25 to a 25 from another piece of code. It may or may not really line up as far as complexity and whatnot. It's really good for relative changes. So we'll add some new information to our test to see if we can execute more of the lines of code. And we run that, and we get up to 27%, and we've lowered from 20, what was it? 25 to 19. So a sizable reduction in crap of our code. Not bad. We add some more. We're going to get it down to 15. So we're at 36% now as far as code coverage. So there's a direct correlation to how much code coverage you have of your tests to your crap index. So the more we do testing, the lower our crap index is going to be, which in general is a good thing. We got it down to 9, and we're at about 54, so about half of the lines of code are being executed. We can do a couple more checks. Our score doesn't actually reduce at that point because our lines of code didn't change. But here's the trend you can see. We started at 18%, and we had this nice big 25 number, and we dropped down to 9, but we're only executing half of the lines of code. This is another challenge that I had with the crap index. It really is only good relative to something else in that code as far as a score. Like 25, when I look at 25, I don't know inherently if that's good or bad. I do know that in this case, 25 was worse than the 19, 15, 11, and 9 that we got by adding more unit tests. There's another way to lower the code, or lower the crap index on your code, and it's refactoring. So we've got this big giant thing. There's a couple of factors involved. One, we have a lot of code paths, right? I mean, you look at this thing, and the number of places where it could branch are pretty high. We have a lot of conditional checks. The other thing is we have a lot of places where we could exit the function. all these, every time we're calling return is a point in the method where it might cease executing. So we've got a lot of branches where there are a lot of decisions being made in code. In general, again, this is super contrived, but in general, when you have stuff like this, it is riskier to modify because you may have missed a condition or not fully understood a particular condition that was being checked for. So one way, I'm not saying this is the only way, but one way we could do this differently is to just take an array of fields and check that each field is set. And now we only have 2 spots where it can return. Our logic is a little bit simpler. We have a loop and 1 condition as opposed to a whole series of conditions. So if we run this, again, to generate a coverage report, we get our crash score all the way down to 3. And we're at 90%. So again, compared to 25, we've made a huge difference, and we did that in 2 ways. We increased the code coverage for our unit tests by executing more lines of code in our unit tests, and we refactored it to make the logic of that method simpler. So fewer points where the method can return, and fewer branches as far as logic flow. Got it down to 3. So again, relative to our 25, I'd say that is our biggest jump, right? 3 to 9, that's our biggest jump in terms of factor. We can do one more thing to our unit test to get 100%. We can check the empty array again and assert that we get false back. And we get 100%, and our crap score dropped. Was it 3.01? So it didn't drop a lot. I mean, 3 is. I don't have enough experience with different code bases to tell you if 3 is what I would consider bottom of the barrel or not, as far as how low you're going to get. But in our examples, that was as low as I was able to get the crap index to go. And we got this down to 100%. We're executing every single line of code. Here's a good example of what I'm going to touch on. You'll notice that it doesn't consider that line of code executable. There are a couple of quirks in Xdebug when it marks a line as executable or not. I don't know why exactly it chooses to do that. It could be something as silly as a trailing comma and lack of trailing comma on that last value. I don't know. So this isn't a perfect science. There's a lot of kind of tweaking and hedging that you'll have to do when you get down to this level of having like 100% and you've already refactored and covered your unit tests. So even at 100%, we're down to 3. But again, that's a huge improvement from what we started, right? 25 to 3. Now, the idea of that is that changing this code, you should feel fairly comfortable and confident in being able to alter the logic of this code and not screw something up. Either a unit test will fail and it'll catch something that changed in the way the code executes, or your crap index will go up. Which, depending if you've got to add some more logic, maybe that's okay. But at least that's something that you can be aware of. Yeah, so my golden rule, my red is totally washed out. 3 is better than 25. That's my golden rule in the crap index. Now congratulations. We spent a few minutes, and you now have accomplished the state of being dangerous enough to go test stuff out. Dangerous enough to try stuff and not have all the information, but enough to experiment. So a few notes on how this works. I mentioned that Xdebug isn't perfect about executing code. You might be okay with that, right? You might just say, you know what, xdebug didn't pick up this line of code as being executable. I'm all right with that, and be okay. Other times you may want to alter the way your code is laid out, just so that xdebug picks up on that properly. Like I said, I can't remember if it's a trailing comma issue or not in that array, but it had that last element in the array where it didn't mark it as executable. I don't know why that was the case. There's some. I'll note also that you don't have to do this with PHPUnit. Xdebug itself has functions that you can call to tell it start tracing executes and stop tracing executes. And then it will return an array of all of the line numbers in the source code indicating which ones were executable and which ones weren't. So if you wanted to process all of that data yourself, manually, outside of PHPUnit and code coverage, you could. I personally haven't had a need to do that. I'm happy with what PHPUnit generates, but you could do that. In PHPUnit, there are some declarations that you might find handy. You may find some conditions. As a matter of fact, I'll probably say you will find some conditions in which the code coverage analysis is insufficient, and you have blocks of code that maybe are initializing things or doing some other activities where you don't have specific tests for that, and you're okay with that. You can tell PHPUnit, don't worry about code coverage for that. So the ignore one at the top, you can put at the top of a class or a function or a method, and it will automatically know, okay, we're not going to worry about code coverage analysis for this particular class function. If you want to do it for just very isolated blocks of code, you can use the ignore start and ignore end. I have run into a few cases where that's been useful. I had a method that just returned an HTTP location header, and I wasn't able to capture that properly in PHPUnit for whatever reason. But it was just one line of code. I was quite sure that if PHP wasn't able to return an HTTP header, I'd have much worse situations. So in that case, I just start the ignore on that one line of code in terms of code coverage analysis. The PHPUnit documentation for this particular section is right there. The documentation covers a lot of steps. Some of the screenshots are old, but there's a lot of details as far as what options you have, how things are treated, and there's a couple other options you can throw in there as well, but these are the ones that I mostly stuck to. Not a technical issue, but as far as a writing code issue, a style issue, is if you're going to use something like this, like ignore or start end, I highly, highly, highly recommend putting comments in your code as to indicate why you are ignoring that particular chunk of code. It's super frustrating for somebody to come along, or even yourself to come back 9 months later, look at this piece of code, and try and figure out why you told PHPUnit to ignore code coverage analysis on that section of code. You probably, I'm certain you had a reason, but your ability to remember that is probably not going to happen. So I strongly recommend leaving a comment. Obviously, that's not a requirement to make it work, but it's super, super helpful down the line. So this is not my laptop, so unfortunately I can't run the code live. It's all up on my GitHub account though, so it's all out there. Excuse me. Any particular questions or other things? We can probably get somebody's laptop up connected and get the code down if you want to run through some of this.
I had one. So in your first example, with the greetings, there was something odd that I noticed. By the time we got to 100% code coverage, sorry, to go all the way back. That's the wrong way.
That one?
Yeah, so one of the interesting things I noticed is that we have 3 tests. One that tests Bob, one that tests Jill, one that tests Jack. We don't have any tests that cover
Others?
anything else.
And that's...
So the high greeting is never being tested, despite the fact that we have 100% code coverage.
Yep. And that is one of those things where you have to be careful. This is a tool to kind of guide you in the right direction. It's not a tool that says your code is now perfect or your tests are now perfect. It's something you're going to run into probably over and over again, to be quite honest. So 100%, like that you may not be done.
Yeah, I mean, you could change pi to something entirely different. And yes, that line of code was executed during all your tests, but if you're not testing a case that actually exercises that,
right,
then you wouldn't ever know that someone changed high to die or something.
Exactly. And so 100% it maybe is a step in the right direction, but not the end goal. Yeah.
I'll say one thing to that, and that's if you're doing test-driven development properly, you wouldn't have that green high in there unless there was a test already written for it. And so that's how you kind of avoid that problem.
Right, that's true. Yeah.
The trick is knowing whether or not. The nice thing about having the code coverage is it gives you a feel for how much your tests are covering. The problem with it not catching things like that is that the only way for you to know that is to actually look at it and have walk through it. Right? The tool isn't fine-grained enough to tell you, hey, you still have some more work to do, even though you're at 100%. So maybe that shouldn't be 100%, maybe that should be 98.
Well, and similarly, in the next example, by the time you refactored it to the array, you could take all but one of the required fields out of that array. You still have 100% code coverage. You might even get a lower prep score by having a short array. I don't know, but you could take out the requirements about month, year, CVC, and country code, and your 2 tests would pass exactly the same. But yet you wouldn't be getting quite the validation that you thought you might have.
Right. Yeah, 100% is 100% according to XDebug, which isn't perfect. The other thing that would be nice, and it's kind of silly to lay it out in these trivial examples, but if you had a method that was a bit longer and had a few more decision branches and stuff like that, and returned in a few places, it would be nice to know if you had code that was unreachable.
That's what that dead code is.
Is that what the dead code does? Yeah.
I tried it and it doesn't actually work.
So it's not just...
In theory it's there, but it doesn't actually work.
Maybe your code wasn't dead enough.
Maybe my code wasn't
It's
dead
just
enough.
mostly dead.
Maybe you had stuff after the...
If it's only mostly dead, there's only one thing you can do. So yeah.
It would be interesting to see what it considers dead. I mean, if you put a bunch of lines of code after return true...
I was going to say, that's what I did to actually test this when I was preparing these slides, was I added extra code after return true at the end here to see if it would flag it as dead code, and it still didn't flag it.
So you could never get 100% code coverage.
No, you know what? It flagged it as code that doesn't execute. So you've got this not executed. Oh, well, that's not, I'm sorry. It treats it as these blank, these white lines. Yeah. And so I couldn't figure out why it didn't mark it as dead code.
Is there a color on that dead code? Is it... I can't tell if it's a little
like
yellow.
a yellowish sort of thing, yeah.
Okay.
Let's see, oh, it's better on here. Yeah, it's a yellow.
But the lines up in this example are white. They're not marked yellow. Interesting.
Yeah, so these are actually white. White. That one little bracket, white. Comments, white. Doesn't bracket. Xdebug, I think, has a flag that's supposed to generate dead code analysis, and that is turned on in the code coverage library. I just couldn't get it to come up. So I don't know if that's a combination of particular versions I'm using or some other issue, but it would be nice if it did that in a little bit more sane fashion. Yeah, Steve.
So going back to what Mac was saying about the code coverage not necessarily, basically the point I guess is that code coverage, 100% code coverage doesn't mean that your tests are all good. It just means that
some test executes every line.
yeah.
Some tests
Your
executes
tests
every line of
execute all
code.
the lines of
Right.
code. It doesn't mean that your tests actually are valid.
It doesn't mean that they're perfect. It doesn't mean that they're 100%. I mean, here's the problem I have with tests, is that you have to write them. And you're generally the same person who wrote the code in the first, I mean, you're writing code. And all of us have the ability to make mistakes in our code, including the testing code. I've more than once run across a situation where we had a light layer now I can't log in. We had a light layer of unit tests that ran as part of the deploy mechanism. They only took a second or two to run. They were just the bare minimum, absolute, these must pass in order for deploy to be allowed. And that was fine 99% of the time. Until we ran into a condition, part of it was some integration testing, ran into a condition that the tests were wrong. And so I couldn't deploy because the tests were failing, even though all the attributes were correct, they were legitimate. It's just that it was one of those things that only came up every so often, so the tests never properly accounted for that. It wasn't the end of the world, but I mean, it's code. I mean, we sometimes make mistakes.
It's better than the opposite problem of thinking that it passed when it shouldn't have, and then deploying it.
Yeah, well, I mean, that's why we had that thin layer of unit tests on deploy, was just the last final sort of, are we really sure, to make that happen. Yeah, so the broader question is, should you have 100% code coverage? And this is going to vary depending on how you guys develop. I mean, my attitude is, once a project becomes sufficiently large, you're probably going to have a much harder time maintaining 100%. So maybe 100% isn't necessarily your target, or your target changes over time.
Well, the example that jumps out to me with that is sometimes I have logic in my code to detect whether it's a development or a production environment. Because the clients don't like it when they get emails every time I run a test. So I don't test actually sending the email to the client. You have to wait for that to be production.
Yeah, and there's
some places where you know you have to do it.
And that's where I point out the ignore stuff. I mean, and there's different approaches to how you can do that. I mean, you may have a stub class that mimics the email, and you check that. But that's kind of get to the point there where you're almost doing integration testing. And honestly, if it were me, and I am not a testing guru by any sense, but my general inclination as a developer would be to do the integration side and say, I have a test email account, it sends it off to that, and I actually go pull it in my unit test, go pull that email back out, make sure it has the stuff I expected it, and determine pass or fail based on that. Which opens up a whole bunch of opportunities for failure if your mail server goes down. But to me, as a developer, that is more kind of the whole circle. Did the whole thing do what I expect it to do? versus just having a stub email class that mimics doing what it's
Of course, I guess I'm probably doing something that I probably shouldn't be. Most people don't. I have static emails in some of my code. So, yeah, if you want it from the data, though, yeah, you can have the exact set.
I have a few cases where we collect debug information. Probably a few static emails in there. But I'm not running unit testing against those either. So it's one after the other.
That might be a case, debugging the code might be a case where the live version is something that you want to use the start code, start coverage ignore, code coverage ignore start. That's the code coverage ignore. And so that you say, I don't expect these lines to ever get run during a test run, and I'm okay with that.
Right, or
this is production only code.
or that they run but you don't have unit tests against them.
Right.
Maybe you're okay with that. That's why I try not to present these as any sort of hard and fast rule. I mean, these are tools that hopefully find useful and have some space for in your development work. I tend to try and aim for flexibility and pragmatism as much as possible. So the reason I started playing with this was because it looked interesting and I was doing some testing and I wanted more idea of how well the unit tests were running as far as executing code. And so we're not using this as widely as I would like internally at work, but it's another tool in the belt when that does come up. Dave, did you have?
I would just have a comment. You may already, I'm keeping related, so you can comment on it.
We'll blame it on you. It's okay.
One of the things you have to kind of balance as well is how many unit integration tests you do. It takes, we have some users that have these integration tests that take 10 hours to run this whole suite with this entire infrastructure. And obviously they can't run that often. A developer at his desk isn't going to sit there. Okay, I'm running unit tests and I'm off the rest of the day, So you can still, there's ways you can like split things out so you don't run the entire thing at a time. You want to be able to have the build kind of quick feedback of, your unit tests can be short, quick, take a few seconds or a minute. That'll get used more often than something that takes 24 hours to go through the whole thing.
Yeah.
So there's all those things you can balance there.
Well, what I didn't cover at all really was setting up PHPUnit, because there's a lot of things that you can do to make groups and other clusters of tests that you can run. You can run a test just by itself, you can run a group of tests by themselves, you can run the entire suite if you want. So there's a lot of different options for how to manage that. However, that said, running unit tests is like the new compiling, right? You saw the old XKCD where the guys are sword fighting on chairs through the office and the boss is asking them, what are you doing? And they scream back, compiling! Okay, keep going, right? Because a compile on a big project takes a day, right? The unit tests are the new compiling.
So make a lot of them.
Your unit more sword fighting if your unit tests take long. You get a big project. I recently ran code coverage analysis for the WordPress unit tests, which are nowhere near 100%. And it didn't even do anything as far as integration outside of WordPress. It did talk to the database, so there were some database calls being made, but that was all local. And it still took probably a good 15-20 minutes to run the test and then build the code coverage analysis. Because that's the other thing is the code coverage analysis is only going to make things slower as far as running the unit tests. All the examples that I ran, that I showed, ran super fast because it's a handful of lines. And it's more or less instantaneous. When you're starting to talk about tens of thousands or hundreds of thousands of lines of code, and you're telling PHP, the Xdebug, to track the execution state of every single one of those, That's more work. More work generally means slow. So it's all trade-offs. There's lots of flexibility though in how you structure PHPUnit, so that if you have a large code base that's broken up, it's very modular, and you're only working on one module, you can run unit tests that affect just that module. Lots of options. Yeah?
Do you have a feel for how many people run the unit tests manually like this versus doing it primarily through something like continuous integration or Jenkins or Travis CI or something like that?
That's a good question. I don't. I can only judge my own experience on that, and that is I tend to run them manually a lot. Because I like to see what I'm doing while I'm writing it, as opposed to waiting for a commit to trigger off. That said, I mean, I think doing stuff on commit is a good infrastructure piece to have in place. Because
at least they're getting run once if the developer decided not to run them manually.
Well, they get run if the developer decided not to run them manually, but the other thing is you get to see, you get to track change over time. So let's say you decide that code coverage percentage and crap index are something that you want to track over time. Well, doing that on per commit is a great way to do that, because then you can pull those values and just say, okay, well, this commit, suddenly our code coverage dropped. All right, well, maybe I need to write more tests. Or maybe I need to refactor some code to deal with the crap index score that suddenly skyrocketed from 3 to 180. I will say, yeah, go ahead.
So another good thing about doing that too is you can test against various environments. You can test against different OSs you have installed on different versions of PHP. You know, all that stuff that, you know, working on MacBook, you know, there's a million other locations, you know, on Wordpress, for example. You can test that with Jenkins a lot easier than you're trying to get all that for yourself.
Yeah. That's probably, to me, that's probably best suited for those automated runs, as opposed to expecting a developer to run it under a dozen different environments after each test. The other thing that I didn't show in the code coverage analysis is that it will also, I only showed the one file. It will generate analysis for all of the code. Like, you know, if you have 100 different classes and 100 different files, it will generate analysis. If you have unit tests for that whole project, it'll run an analysis against that whole project. So it'll generate a bar graph that says this percentage of your code is between 60 and 70% code coverage. This percentage is between 80 and 90. So you get a feel for where you're at in your tests. It'll give you a crap index for the entire code base if you want. I found that to be less useful. I tend to drill into a particular item as opposed to worrying about too much about the overall. I mean, it's probably helpful if you want to improve the overall project, but as a developer, I'm usually working on one piece as opposed to worrying about all 30,000 lines of code. I'm worried about this one section. All right, well, if there's no other questions, again, slides and code are all available on my GitHub account. You can reach me on IRC. I have the super original nick of Joseph Scott. JosephScott.org, I have a contact page, and Joseph Scott on Twitter. And other than that, I think we'll probably adjourn to Applebee's. I'm done.